Assalamu alaikum. So we have so far covered until normalization. The next chapter we are going to do is uh, about storage. How on the back end, database management systems are taking care of storage. This is something usually we are not directly, we as database users or developers are not directly involved with. Uh, System developers who are developing databases like MySQL or Oracle, they are taking care of this for us. But it is always helpful to understand the concepts, what goes on behind the scene, because we are just looking at the logical um level, and this is where the physical level is. So let me share with you my slides. So here it is, disk storage, basic file structures and hashing. In this chapter, the basic concepts which are covered include physical database storage structure, disk storage devices, files of records, operation on files, unordered files, ordered files, and hashed files. And at the end, RAID technology. So if you have studied this probably in early in your degree program in ICT and in other courses about the primary storage and secondary storage devices. Primary storage, just to recap, primary storage is basically random access memory or cache memory or flash memory. So one of these. So cache memory is static memory, which basically keeps the thing static in there, saved there. Main memory is volatile. Its cost is decreasing, but still it is expensive to keep all the data in there. And also the other problem is that it is volatile. So that's mean if your computer is down, shuts down, everything in there will be removed, or it gets removed automatically. Then there are secondary and tertiary storage devices like hard disks. So those are magnetic disk, optical disk, tapes. Then you have removable media like CD or DVD or those type of uh, basically storage medium. Now these secondary and tertiary storage devices, they have large capacity. If you think about now that hard disks are coming in 8 terabytes and 16 terabytes, and if you compare it with your main memory RAM, so far we do not think about having that much RAM in our computer. So first the data gets copied into the primary memory, and then it is processed and it goes into one of your secondary memory devices, whether hard disk or tapes or optical discs, and gets stored there. So the processing happens in the memory. All the processing is happening, but the storage is on these secondary storage devices, and it is happening behind the scene automatically, so we do not notice that what's going on in there. Basic concept of database is that the data is persistent. Data is there to stay. It is not volatile data. It is not something that we are just calculating, and we will be removing it. But the concept of database is that the data we are manipulating or data we are working on has to stay. Most of the databases store their data on magnetic disks. So hard disk, basically, if we think about our servers or even our laptops or our desktops, so we work on a database. Take an example of MySQL. You create a table and you enter a new row. As soon as you finish adding that row, that data gets stored on hard disk. And then next time you go there, your data comes from that hard disk, and then you can manipulate it or work on it in the memory, and then it gets updated or deleted or whatever functions you are doing. So this non-volatile nature of secondary storage prevents the data loss, because if anything happens with electricity or your computer shuts down, you have a copy in your hard disk. And the cost is as compared to memory. If the data is in the memory, then memory is quite expensive. RAM is quite expensive. On the other hand, per unit cost of data storage on hard disk is quite less. Hard disks are not that expensive if we compare it with RAM. So these disk storage devices basically provide high storage capacity with low cost. The data is stored on magnetized areas on magnetic disk surfaces. And a disk pack contains several magnetic disks connected to a rotating spindle. So there is a spindle in between, and there are several magnetic disks that are connected with it. And then on those magnetic disks, the data gets stored. Then on those magnetic disks, each magnetic disk has circular tracks on those disk surface. And those could be from few hundred to few thousand. Basically, on those tracks, then we have sectors. And on those tracks, the data gets stored. And tracks, typically, the capacity of a track to store data is from tens to 150 kilobytes. So in this way, you can calculate how many disks are being used. So here is a visual display of how a typical disk storage looks like. So this one is a single-sided disk with read-write hardware. So in this, the second one, B, is the first one. A is only one disk, and the B one is the whole pack. So pack of disks, and there is a spindle in between. So you can see that there is an arm and actuator and a pointer, which is read-write head. So that read-write head is reading and writing on those tracks. So you have tracks on those disks. So disks rotate, and the data is being written or being read from those disks. So as I earlier mentioned, those are tracks on the disk. They are subdivided into blocks or sectors. And in one sector, you can have a lot of information being stored. This information, this division of a track, so you can see there were tracks on one disk. So there is a division of track into sectors. This information is hard coded on the disk surface and cannot be changed. So there are several type of sector organizations. One is called a portion of a track that subtends a fixed angle at the center as a sector. So you can have different companies, different manufacturers, they use different algorithms to do that, different ways to do that. So a track is basically divided into blocks. The block size B is fixed for each system. And a typical block size is from 512 bytes to 8,192 bytes. So you will have numerous blocks in one sector. So here you see track, you have a track, and then on that track you have a sector. So this sector, there are numerous sectors on a track on a disk. So sectors subtending a fixed angle. So this, the first one. And the second one in B is basically sectors maintaining a uniform recording density. So in this way, you can have one sector, two sectors, and three sectors on that disk. So what happens is the read-write head, which is connected through actuator, it moves to the track that contains the block to be read. That data needs to be transferred to the RAM, and then something has to be done. So in this way, the read-write head is basically moving that data. And disk rotation, because disk is on a spindle, so spindle is moving. So disk rotation moves the block under the read-write head for reading or writing. So in this way, that blocks goes there, and that read-write head reads that information. So a physical disk block address a cylinder number, the track number or surface number within the cylinder, and block number. So all these three informations are kept, and using that, then information is read from a disk. One thing that if you are dealing with large quantity, a large amount of data, so if your data is like, let's say, in millions of records, now on a hard disk or on the secondary storage device, it is slow as compared to your primary device, primary storage memory. Or now these flash drives are coming. So those are faster, much faster than this old mechanism of magnetic disks. So reading and writing is time consuming because of the seek time and rotational delay. And then there is a block transfer time, because then block has to be transferred. So this all comes up to basically slowing the database access. We can use double buffering to speed up the transfer of contiguous disks blocks. So if you are reading one block, the next block is now very close, so that can be speedily accessed. So you can buffer it and see if it is being requested or not. Because if you are dealing with large records, so one record may spill into the next block. So if you read both of those blocks, then that may fasten the whole process. So these typical disk parameters help in understanding it more, but this is more of a more technical. So let's look at records. So what are records? So we have in databases and in file system, we discuss about records. What are those? So each record contain maybe, let's say, a student record. So student record can have student ID, name, address, phone number. So all of that one chunk is one record. So these records could be fixed or variable length records. We saw that in databases there are data types like varchar, which is variable data types. And then there are fixed data types like integer and char and binary, so fixed and variable. Record contains fields which have values of a particular type, so amount, date, time, age. So we have a record type and data type. So let's look at a typical database. So if you are storing an integer, let's say amount, so it will take 4 bytes. That is a fixed size. Then long integer will take 8 bytes. Real number will take 4 bytes. Boolean 1 byte. Date takes 10 bytes. And fixed length string of k characters take k bytes. So if we combine them all, that will become one record, and we will have a complete length of one fixed record. But if it is a variable length, then variable length can be mixed into one record. We can have fixed records as well as variable length fields in a record. Then special characters are used if we have a variable length fields. So looking at this example, so if you look at A, example A, in that is the whole thing is a fixed record. So name is fixed. How many bytes we have to look at. Then we have SSN, then salary, job code, department, hire date. So together all of them are taking 71 bytes. In B, we have two of the fields, name and department, are variable length, whereas SSN, salary, job code, they are fixed length. Now this separator character is being used to separate one variable length field from the next field. And there is a terminates record in case 3, because in case 3 all three fields are variable length fields. So a terminates record is being used in that case. Blocking. The concept of blocking is that you have a record, a typical record, and that record you are storing in one block. So that is the concept of blocking. Now, in real time, sometime what happens is that it takes more than one block to store a record. So blocking factor, BFR, refers to the number of records per block. So how many records are in one block, or maybe a record is taking more than one block. And there may be cases that empty space is there in a block if an integral number of records do not fit in one block. Spanned records are those records that exceed the size of one or more blocks and hence span a number of blocks. So if you have a large record, then that may not fit in one block, so it will spill into second or third, or so it will span more than one block. So those are called spanned blocks or spanned records. Now, this information, the whole data is stored in a file. So file has records, so files of records. So a file is a sequence of records. So you have all those records that are associated with one set of data. Those all records will be in one file. And then each record has a collection of data values. So for file, a file descriptor or file header has information that describes the file. What is the name of the file, what are the data types, and what are the addresses of the file blocks on disks. So file contains this information. File header contains this information, that where are those records that have been saved in that particular file. So it has that information, that where are those blocks where the data resides, the records reside. So these records are stored on disk blocks. And the blocking factor, BFR, for a file is basically the average number of file records stored in a disk block. So how many records are stored in a disk block? Again, file can have fixed length records or variable length records. So file is concerned about more what records are in one file. Now these files can be unspanned or spanned. So unspanned files are those files or file records where one record can not span two blocks. So one record is only in one block, whereas spanned file is where a record can be stored in more than one block. So you are using 2 blocks or 3 blocks, or how many blocks you are using. So that becomes, that is called spanned file. So if you think about now a file will have many records. So now this file physically on a disk block, all the records that correspond to or that are in one file, they could be contiguous, like they are one by one together, or they are linked, or they may be indexed. So there are several ways this organization can happen. In a file of fixed length records, all records have the same format. So you have 71, let's say 71 bytes. So all the records are taking 71 bytes. So this, in this case, usually unspanned blocking is used. So you have all those records and you do not use span. Whereas when you are using variable length records, then you have separated character and fields, so you use span blocking in such case. So take this example. Your A case is unspanned, so you have record 1, record 2, record 3 in block I, and then you, because another record 4 cannot fit in the space, so you leave it blank and you go to next block. So no record is spanned more than one block. Whereas in spanned case, on B case, we have this record 4, we are partially storing it in block 1 and then partially in block I plus 1. So far we have studied how records are maintained, what are storage devices, how records are maintained. Now records are part of a file, how files are maintained. Now operations on files, there are several typical operations that we can do on files. So we are able to open files. So when we say we are opening file, we prepare that file for reading and writing. And then the system allocates appropriate buffers to hold file blocks from disks and retrieve the file header. And then sets the file pointer to the beginning of the file. So what is the current record? So this is how then file is opened in a buffer, and then we store it back on the storage device. Find is you find searches for a record that satisfy a certain condition. Let's say you have a condition you are trying where name is equal to Muhammad. So you are trying to find that record in the file, and the first instance you find it, then the pointer goes there. Find next basically, as the name suggests, searches for the next file records which satisfy that condition that we have set. And then cursor moves there, or the pointer moves there. Reading is basically reading the record which is current file record, where your pointer is in the file right now. And inserts a record in the file and then makes it the current file record. You can insert at the end of the file. You can, so you, where your pointer is, you will be inserting your record in the file. Then deleting is removing the current file record and modifying similarly. So these are all operations you can look into, which are possible in files. Files are of different types. There are unordered files like heap. So heap is like a pile. So you are just putting, there is no order in there. So you are just putting in things, and then you have to, so in this case you can imagine that insertion would be very fast because you are just dumping in things. It's just like a dump. So you are putting in stuff. But when you try to find something, retrieval will be expensive. It will take time to find something in there because there is no order in that heap. On the contrary, we have ordered files or sequential files. In sequential file, all file records are kept sorted by the value of an ordering field. So you are ordering them, let's say by ID or by student ID. So then you will have ID number 1 and 2 and 3 and 4. So in this way, you are keeping them in order. What this will help is that reading will be quite efficient. So if you want to go to record number, let's say you want to retrieve student ID 150. So you will just multiply that with the number of bytes per record. So you have, if you have 71 bytes for one record, you multiply that with 172 and you will be at 172 ID record. Insertion is expensive because in this case, you need to keep the record in a sequence. So if you have inserted already data for 172 student ID and then data for 150 student ID comes, then you have to go in and make that ordered. So a binary search can be used to search for a record on an ordering field value. So this is your ordered file. You have block 1, block 2, block 3, block 4, 5, 6, and this way block n+1. So you are storing them in particular order. Let's say this order is by alphabetical order because we are using A, Aaron, Ad, and Abbott, Diane, and then AD starts with block 2, AL start with block 3, AL again block with start 4, AN block 5, AM block 6. So in this way you continuously use that ordering. Average access time of these blocks is, if it is an unordered heap, then you have to do a linear search. So you have to go in and try to find that. So its average block to access a specific record is B by 2. In a sequential scan, it is B by 2, and in an ordered binary scan, it's log 2B. So then there is a concept of hashed files. So in hashed, what you do is you use hashing functions, and based on that hashing functions, those hash keys, you determine where this record will go. So a record with hash key value k is stored in bucket I, where I is equal to hk, and h is the hashing function. So in this way, you determine where to store a particular record. So hashing helps in searching. Search is very efficient on the hash key. Sometime what happens is collision happen, because if the block is already full where you are sending that record, so there is a concept of buckets, numbered buckets in hashing. So a file blocks are divided into equal sized buckets, 0, 1, 2, up to m-1. So in this m-sized buckets, your hashing function determines which bucket your record will go to. And what if the bucket is already full? Then you have to come up with those. So this overflow records is where you have to use some algorithm. So there are several ways. One way is open addressing. So what you do is, if that bucket is already full, then you use subsequent positions in order until an unused position is found. Chaining is another method in this. Basically, you extend that bucket through array for overflow positions. Multiple hashing is, you use one hashing functions. If that is full, then you use another hashing function, or maybe third time. So you have several hashing functions which helps you to find a location for your record. So here, if you visually see it, you have buckets, and then those buckets are stored on the physical disk, and your records goes into those buckets. Overflow is one of the disadvantages or challenges. So there are several techniques, as I already mentioned. There is another technique that you keep your hash file 7 to 80% full. You do not fill it completely. Then hash function should be smart enough that they distribute the records uniformly among several buckets. Main disadvantages of external hashing is that if you have fixed number of buckets, then what if your number of records grow or shrink? How you are going to address that issue? And also, ordered access on the hash key is quite inefficient, because then you have to first sort the records and then you go in and order. So here is a visual display of how you can take care of overflow in hashing. some more concepts about dynamic and extendable hash files that you can further explore. Then there is now, so far we have been talking about one storage disk. So your data is going into one storage disk, and then you read that disk and update that disk storage. There is another concept of RAID, which is redundant array of inexpensive disks. So in RAID, basically what you do is you use multiple disks to store your record, because in databases, data can grow exponentially. So we are talking about terabytes, multiple terabytes of data. So let's say you have, let's say, 15 or 20 terabytes of data. Now, one disk, handling it in one disk will become quite slow. Also, that huge disks sometimes are very expensive. So what if we use multiple 16 1 terabyte disks? Those are inexpensive, and so, but we need some kind of technology that can handle it. So RAID is a technology which helps in distributing. Basically, the goal of RAID is to even out the widely different rates of performance improvement of disk against those in memory and microprocessors. So if you have a file, so file data gets stored on disk 0, 1, 2, 3, and RAID technology is taking care of it. Basically, those are small independent disks acting as a single high performance logical disk. So those 4 disks are performing just like one disk. So concept of data stripping is used, which uses parallelism to improve disk performance. And this technique, this concept, data stripping, basically it distributes data transparently over multiple disks to make them appear as a single large, fast disk. So in physically you have 4 disks, but logically you think of them as one disk. So this is what the data stripping and RAID technology is. So your data is being copied on multiple disks. Some more information about RAID technology and how it is used. But basically, the concept is around how you can use multiple disks to mimic as one large storage device. There is also a concept of SAN, storage area network. Now, if you think about Google, or you think about Amazon or YouTube, we are talking about petabytes of data. Now, we are not talking about 1 disk or 2 disk or 5 disk or RAID. So we need a huge storage area, as in huge storage. So this concept of storage area network, SANs, that is implemented in basically in a SAN. Online storage peripherals are configured as nodes on a high-speed network and can be attached and detached from server in a very flexible manner. So you are using networking to store data on multiple locations. So this is not only helpful in connecting data to several places, but also you can have copy at different locations. So main advantages of storage area networks are flexibility of many-to-many connectivity among servers and storage devices using fiber channel hubs and switches. So fiber is used for networking. So for that purpose, the data moves quickly. So fiber optic cables are, and high speed connection is used in that. There are certain challenges, but now bigger and larger organizations are using storage area networks for their storage needs. So this was a quick recap of storage back end, what's happening on the back end in databases. And basically, if you have further interest, we can discuss it during our next discussion sessions. I think that's enough for this chapter. A quick recap, and we will talk on Monday about this. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.